Hi friend, how are you? Today my discussing topic is about inside the drive mechanism box. We all know that the drive mechanism box is attached with the power transformer. What is the reason behind the attachment of the drive mechanism box? The drive mechanism box has two functions. One is the on-load tap changer purpose and off-load tap changing purpose. So generally nowadays on-load tap changing are just going on everywhere and off-load tap changers are totally obsoleted. From the drive mechanism box, the connections are being with the RTCC remote tap changing cubicle. These remote tap changing cubicles we can easily changing the tap according to the frequency, according to the current voltage level. It may be controlled by the load dispatch center or from the substation control engineers as per the requirement basis. If the requirement is there to changing the tap to maintain the balance voltage and balance frequency, we operate the tap from lower to higher according to the situation is concerned. Generally the transformers has a number of tap 17. As on the experience basis, I have worked with the 20 MVA transformer, 10 MVA transformer, 31.5 MVA transformer, 50 MVA transformer, 80 MVA transformer, 160 MVA transformer and 200 MVA transformers. All the transformers has the 17 number of tap. These 17 number of tap are just divided with some register, and these registers value will be converted to the TPI. What is TPI? TPI is the tap position indicator. As per my experience is concerned, the registers in between the tap of the transformers is 1 kilo ohm. So if we are considering, I have drawn this picture, this tie rod is connected with the OLTC chambers of the transformers, and these hinges and the pipe and the rod is just entering inside the DM box, and this DM box rod is just connected with a circular plate, and on the circular plate and the below the circular plate the resistance and the connections between a connecting rods and a connecting point are as like as this. If you open the DM box and see that these types of circular plates and this tie rods is just connected with the OLTC chamber. As per the simplicity of the understanding, I have drawn the resistance in between the tap 1 and tap 2, tap 2 to tap 3, tap 4, tap 5, tap 6, tap 7, tap 8, tap 9. 9 number tap as in 3 position, 9A, 9B and 9C. So I have drawn for the simplicity one tapping position 9. Here the 10 to 11 resistance is connected, 11 to 12 resistance is connected, 12 to 13, 13 to 14, 14 to 15, 15 to 16, 16 to 17. All the connections between the two tap position, the resistors. If you are just open the DM box and see very gently, then you obviously see the registers are connected between the tap position, and these resistance value are converting to the TPI on the remote tap changers. This is the RTCC. It is just placed inside the control building or control room, and this is inside the DM box. This is inside the DM box. This is the DM box. It is being attached with the transformers, power transformers, and the connections from the control cable. As per the requirement basis, we are connecting with this circular resistors path with the RTCC TPI, tap position indicator, and this tap position indicator has an 3 ferrule number N209, N213, N211. This 3 has a value N209 always connected with the minimum port, minimum terminal. N213 is in common terminal and N211 is in maximum terminal. Maximum terminal means tab number 17. If we are just rotating the tab position from here, I am showing that the tab position in 17. That's why we are just connecting this diff, black color diff, and the connections with the tab position or tab resistance. So here, what is the measurement here? Measurement here between the resistance of 1 to 17. The total resistance it is showing. If the resistance is 16.15 so 16.15 kilo ohm, it will be converted to the tab number 17. Tab number 17. Here show the tab number 17. Because as per the picture is concerned, I am just connecting the diff with the 17 number tab. That's why we are just writing here the 17. So tab position in 17, the resistance is 16.15. It is the maximum, it is the value, maximum value, because it has a tolerance of 5%. After this video, I will make a video on the resistors color coding. This color coding, you will see this video and you can easily understand what is the tolerance, what is the color coding means. I will do the video after that, this video. So what is the connections? It is between the 17 number tab, and for because it is not the 3D diagram, that's why I just draw this. Actually the position is from here to here. So this div and this div will be connected with this position. That means the total resistance of 17. If we are just changing the position of the tab from 17 to 16, so the 1 to 16 resistance will be counted. 1 to 16 resistance will be counted, and it will show the 16 number tab. When you are just decreasing the tab to the 15, it will measure the resistance of the 1 to 15 and it will show on the here the 15 number tab. The main funda of the conversions of the tab position, this is the physical tab position. You can see the physical tab position when you are just rotating the tab risers or lower. The physical hinge will just come out, a circular plate is there, and the circular plate has just rotate and stop to the positions of the tab as per your requirements. You are just changing the tab from 17 to 16 to it will show the 16 number tab. 16 to 15, 15 number tab. 15 to 14, 14 number tab. But what is the conversions between here to here? Here to here, the main conversion is the resistance value, a resistor value. If the resistor's value is right in conditions, good in conditions, and in the tolerance level, within the tolerance level, it will show the right tab positions from physical tab position to the electronics tab position. If the tolerance of the resistors will be decreased or there may be some error, so you will see the wrong tab position, the remote tab position. So it is generally not happened, but sometimes these types of problem you can face. I have faced these types of problem. That's why I have just doing this video for the knowledge of my subscribers and also for the technical personals who are just doing their duties in the substations or in a power plant. When these types of problem, the value and tolerance of the resistance will be there, the value of the two position will be changed. The physical position will show maybe the 10, but the electronics or RTCC position will show the 9. Why 9? Because the resistance is decreasing here. If the value, suppose if the value is 8 point, for the 9 tab the value is 8.25. If the value is predefined value is 8.25 registers, if it will calculate, then the tab 9 will be shown. For suppose for the 10 it will be 9.25. If the 9.25 will not reach, when it is on the tab 10, it will obviously show the 9 number tab, because the value is decreasing here. Suppose the value is decreasing to the 8.55, it will show the 9. When it is just near or 9.25, it will show the 10. For the 17 number tab, it will obviously show the 16.15. If the 16.15 kilo ohm will show or calculate, then the tab position 17 will be shown the RTCC. So it is a predefined value. It is very important. These types of problem generally not happened in the substation tab position or a OLTC, but it sometimes it is happened in my 15 years careers. These types of problem is the first times I have experienced. That's why I have just shared this experience with my friends and obviously my subscribers. They will if face, don't worry, it will be solved with the discussions with the manufacturers and the tab manufacturers. Obviously it may be the SRMR or CTR whose tab changing drive mechanism box is just connected. You have to consult with the engineers of the manufacturers, then you can change the registers accordingly as per the guidelines, as per the consultation is concerned. If the engineers of the manufacturers will come, that will be very much effective for the systems, because this resistance, the main fund of the resistance is to decrease the value of the current and just restrict the value of the current or the voltage. So if you are not properly color coded resistors put here, that will be that maybe the dangerous situations may be happen. So obviously consult with the manufacturers which types of color coded resistance, which types of tolerance level resistance should be put here for the actual tab position showing. So if the value of the resistors will decreases, the tab positions will show wrong. So this is the basic concept that I have just experienced yesterday in my substations. This is the most important things. I think friends, you obviously understand what I am want to say. These types of problem are just happening in 1000 transformer or in 2000 transformer. In one transformer these types of problem is just happening. If the value of the resistance will be decreases, this will be there. So friend, if you interested, please subscribe my channel and press the bell icon for more updated or practical based video. If you think so that my video is sufficient for your knowledge, please and for your help, obviously subscribe my channel and share my channel with your friends and colleagues. Obviously share my channel with your friends. Thank you very much.